Hi guys, in today's video we are going to continue from where we stopped. Remember last time we were treating matrices and determinants, and we discussed about the operation of matrix. We discussed the multiplication, the addition, the subtraction, and we discussed the types of multiplication, the scalar multiplication and the matrix by matrix multiplication. But today we are going to continue our work from transpose of matrix. After the transpose of matrix, we are going to treat cofactor, treat the determinant, and inverse matrix. If there is time, we continue with the simultaneous equation on matrix using the Cramer's rule and the inverse method. Yes. On transpose, the meaning of transpose means that we should just change all the rows to column for each matrix. Let's take for example. Go. All right. Let's take this one as our first example. Example 1. Now, given that A equals to this, find the transpose of A. We use this small t on it, the t that is of power of A as the symbol of the transpose. So alright, now as for the transpose, remember I said that it is a method in which we turn all the rows to column for each set. Let's say from here now our first row is 3 and minus 4. Then it's going to turn to our first column now. We have it to be 3 and minus 4 now after transpose it. Then for 2 and 8, we have to do what? 2 and 8. And this is the transpose of matrix. Then for the transpose of this as our example 2, and as well as we have P as this, our matrix, then the transpose of P, which is P transpose, equals to all the rows. We have the first row, second row, third row. All the rows we turn to column. Then we have 5 and 2. We have 3 and 3, which is this and this. Then we have 7 and minus 1, and that's the transpose of Q. For transpose of Q transpose now, all the rows turns to column. We have to be 5 minus 3, 1, and we have 2, 3, and 4, and that's the transpose of it. And in case they may ask us to use it to solve any particular question, remember we have gotten our P transpose and we have gotten our Q transpose. If they ask us to find the product between them now, just multiply our answer. We have P transpose times Q transpose. Since our P transpose is 5, 3, 7, 2, 3, minus 1, and our Q transpose is 5, 2, minus 3, 3, 1, 4. Then we do the normal multiplication. Don't forget how we multiply matrix and matrix. We have done that in the previous video. If you were not there, or you have not seen the video, you can check the previous video. Then we have P Q transpose. Now equals to this times this plus this times this one plus 7 times 1. We now have to be 5 times 5 plus 3 times minus 3 plus 7 times 1. Do the same thing for this side too. For the second row, plus 3 times 3 plus 7 times 4, 7 times 4. We are done with that. Then we come to the second row. For the second row, we have it to be 2 times 5 plus 3 times minus 3 plus minus 1 times 1. Then we do the same thing for this one. We have to be 2 times 2, then plus 3 times 3, then plus minus 1 times 4. Then our P transpose, Q transpose, the product is now, this one is 25 minus 9, then plus 7. This one is 10 minus 9 minus 1. This one is 10 plus 9 plus 28. This one is 4 plus 9 minus 4. Then from here we have it to be, this one will be 23, this one will be 0, this one will be, then this one is 47, while this one is 9. And that is the P transpose times Q transpose. And that's that. The determinant. The determinant is just a way in which we use a member to represent a complete matrix set. And to do that, we have methods of doing that. Two methods. If it is 2 by 2, matrix, and if it is more than 2 matrix, let's say maybe 3 by 3 or 4 by 4. In 2 by 2, let's say we have A equals to A, B, C, D. Yeah, to find the determinant of this is we use this to multiply this. We have A determinant. We use these two stroke to represent determinant, or at times they can write depth A like this. Then A determinant is the same thing as in the modulus to represent determinant. A determinant is the same thing as this one times this, which is A times B, minus this one times this one, which is C times B, like that. So anything from here is the determinant of these matrices when we are talking about 2 by 2. Let's take this as our first example. Let's say we have the determinant of this is given as B and is given as 4, 5, 2, 6. Immediately you are ready to do the determinant, you change this bracket to straight by the modulus. Then B determinant now equals to this times this minus this times this. That has to be 4 times 6 minus 2 times 5. 4 times 6 will give us 24 minus 10. Therefore, the determinant, B determinant is same thing as 14. And that is it. And in 3 by 3 matrix, let's take this as example. Alright, for the determinant of A, if A equals to 5, 6, 8, for the first row, 4, 3, 1, second row, 1, 5, 7, third row, the determinant of A, which is this, is given as 5, 6, 8, 4, 3, 1, 1, 5, 7, which is the same thing as, on the determinant of 3 by 3 matrix, we need to give them signs. This is plus, minus, plus. Now we are following the first one, and it is the easiest row to follow. Now the determinant of this will be, on 5, we have 5, plus 5, then we pick the remaining one that is not causing it from this, which is, we have 3, 1, 5, 7. We have 5, okay, 3, 1, 5, 7. We find the determinant of this. Then minus, because of this minus on it, we have minus 6. Then we pick all the member that is not passing through this route. We have 1, 7, 4, and 1. If we have 4, 1, we have 1, 7. And for the last number here, we have 8. For 8, we pick the minor of 8 too. The minor is 4, 3, 1, 5. We have plus 8, 4, 3, 1, 5. 1, 5. Then we now find the determinant of this. We have it to be 5 into bracket. This one and this one minus this one and this one. Remember the method we use in finding this. That is this one. Therefore, we have it to be 3 times 7 minus 5 times 1. Then we have here, we have minus 6 into bracket. This one times 24 times 7 minus 1 times 1. Then we have this to be plus 8 into bracket. 4 times 5 minus 1 times 3. Then from here now we have 5 into bracket 21 minus 5 minus 6 into bracket 28 minus 1 plus 8 into bracket 20 minus 3. Then 5 into bracket, this one is giving us 16 minus 6 into bracket 2 plus 8 into bracket 17. Then from here now, okay, we have 5 times 16 is 80. This one times 27 is 162. 8 times 17 is 136. By having everything together, we have our determinant, which is A determinant equals to 54, which is inverse of a square matrix. In inverse, okay. Now we move to inverse of 2 by 2 matrix. Actually, we solve them differently, but one thing is common to them. We have, let's say we have matrix A. The inverse of matrix A is always written as this, which is we have A raised to power minus 1, which is the same thing as 1 over A. So as a result of that, we discover that when we multiply A inverse and its determinants together, it will give us the adjoint of A. It will give us the adjoint of A, or we call it A adjoint. Let's say adjoint of A. Then from there now we now conclude that, okay, instead of using this, we can find the inverse by dividing both sides by what? The determinant of A. If we divide this side with the determinant of A, we have A, and we now have adjoint A over A determinant, and that is the most widely used formula for finding the inverse of A. Let's take for example 1. If D equals this, let's say our D equals to 7, 4, 3, and minus 1. Find inverse of D. Inverse of D is, remember the formula, D inverse equals to adjoint of D divided by D determinant. D determinant. To find the adjoint of 2 by 2 matrix, what we just need to do is to transpose the principal diagonal. We call this the principal diagonal. And we change the sign at the back of the number or whatever in the ordinary diagonal. Then D or adjoint D now equals to 1 is minus 1 is coming here, 7 is coming here. We have minus 1 and 7. Then the ordinary diagonal just change the sign. Nothing is changed apart from the sign at the back. We have a minus 3. And this is the adjoint of D in 2 by 2 matrix. Then the next thing is to substitute in this formula. Before you can substitute, you need to find the determinant of D. Then D determinant is the same thing as our D. We have it to be 7, 4, 3 minus 1. Then this one times this one will give us 7 times minus 1 minus 4 times 3. Remember from our previous knowledge, please have to find the determinant. Then the determinant of D now equals to minus 7 minus 12. Then which is D determinant equals to minus 19. Then it is this minus 19 we are going to use to divide this adjoint to get the D inverse. Then D inverse now equals to minus 1, minus 4, minus 3, and 7 divided by minus 19. You can easily write this one by putting this 1 over minus 19 into brackets minus 1, minus 4, minus 3, and 7. And if you like, you can use this 1 over minus 19 to open the bracket. If you use it to open the bracket, it's just as if you are using it to divide each member of the matrix. Therefore, we have it to be, if you bring it here, we have it to be minus 1 divided by minus 19. And we have minus 4 divided by minus 19. And we have minus 3 divided by minus 19. And we have 7 divided by minus 19. Where we have it to be, D inverse is the same thing as 1 over 19, 4 over 19, 3 over 19, and 7 over 19 minus. And that is that and that. And if you leave the answer and you still the same thing. Okay, don't forget to subscribe to the YouTube channel Maiwa Bashir or Moshid Bashir Maiwa for your mathematics and physics video. And if you have any question under the topic treated, you can post it in the link description below or in the comment section. Let me use this one as the final example for the day. Example 2. If x equals to 2, 3, 4 minus 1, find x inverse. Solution. Remember that x inverse is the same thing as adjoint x over x determinant. Then as a result of that, we need adjoint x and we need the x. The adjoint x, remember this is 2 by 2 matrix. Just change the principal diagonal and change the sign at the back of the ordinary diagonal. Then adjoint x equals to minus 1, 2, then minus 3, minus 4. Now then we have the next thing is to find the determinant of x. X determinant equals to, use this to multiply this, minus, so you use 4 times 3. Therefore, we have 2 times minus 1 minus 3 times 4. Then we have to minus 2 minus 12. Then x determinant equals to minus 14. And then if we solve this one together, we have our x inverse equals to minus 1 minus 3 minus 4 2. Everything over minus 14. Then we can bring it to the side. We have x this one minus 14 is written as minus 1 over 14 to bracket minus 1 minus 4 3 2. If you like in the bracket, if you use it to open the bracket, you have it to be x inverse equals minus 1 over minus 14 and minus 3 over minus 14. We have minus 4 over minus 14, and we have 2 over minus 14. 2 over minus 14. And this is the same thing as x inverse equals to 1 over 14, 3 over 14, 4 over 14, and 2 over 14. And that is that on that. So when we next from inverse of 3 by 3 matrix, and we do the cofactor before we do the inverse of 3 by 3 matrix, and we move to the simultaneous equation using matrix method, both inverse and Cramer's rule. Don't forget to subscribe to the YouTube channel Moshood Bashir Maiwa and click the notification button so that you'll be notified when we upload video. Thanks. See you in the next class.